Hello, my wonderful pre-calc students. Today we are going to do exactly what we did yesterday, section 6.2, inverses and determinants, day 2. Today is basically just going to be a review of yesterday. We're going to just do U-tries. So ideally you're going to be pausing the video and trying the problems yourself, and then pressing play and watching me recap how to do it. So the first type of problem we are going to try is going to be determining if two things are inverses. So determine if matrix A, which is -3, 2, -2, 1, and matrix B, which is 1, -2, 2, -3. We are going to determine if matrix A and matrix B are inverse matrices. Except that's not how you spell matrices. Good thing I'm not graded on spelling. M-A-T-R-I-C-E-S. Okay, so pause the video now, try to do this on your own, and then when you hit play, I'll go over it. Alright, so in order to determine this, we need to do both A, B, and B, A, because matrices are not commutative, so commutative property is 2 times 6 is equivalent to 6 times 2. Not necessarily with matrices. So matrix A, -3, 2, -2, 1, times matrix B, 1, -2, 2, -3. And then you can also be checking your work right now. So for multiplying, I'm going to take this row, multiply it by this column, and add. So -3 times 1 plus 2 times 2. Then I'm going to do the same thing, but for my second column. So -3 times -2, 6. 2 times -3, -6. -2 times 1, 1 times 2. -2 times -2. And 1 times -3. And I do want to see one line of work like this, and then we can add them together. So -3 plus 4 is 1. 6 minus 6 is 0. We're left with 0, 1. So yay, we have the identity matrix. So it works for AB. Let's confirm it also works for BA. I'm going to set up my matrix multiplication first, show a little bit of work, and we'll see what happens. Okay, so 1 times -3, -2 times -2, 1 times 2, -2 times 1. 2 times -3, -3 times -2, and then 2 times 2, and -3 times 1. And some of you wonderful stubborn pre-calc students might be saying, yeah, well, I can kind of do this in my head, it's easy. That's fantastic, but if you would like full credit on your quiz this Friday, you need to verify AB and BA and then make a conclusion. So since, wow, I really can't spell right now. Hopefully my spelling improves because I start grad school in June, and I will be having to write a lot of papers. Okay, so since AB, matrix A times matrix B, is the same as matrix B times A, and it equals the identity matrix, we can conclude these are inverses. Hopefully I spell Ms.Caesar. Okay, awesome. Next problem, you try. Yeah, so this is all the required work. You need to show all of A times B. Set up not necessarily if the order is already shown, but you do need to show a line of work, and you do need to show that it equals the identity matrix, and then you must do it for the second problem, or second matrix multiplication. Okay, you try again. Now let's do an example of determining the inverse of matrix B if it exists. Hopefully you remember when it does and doesn't exist. If you don't, refer back to yesterday's notes. So matrix B is going to be 6, 4, 9, 6. Why don't you pause the video and try to do this on your own? Alright, so first step in determining an inverse is we need to determine the determinant. So the determinant, remember, is going to be that matrix in some bars like so. It looks like the absolute value, but it's different. And we do 6 times 6, so diagonal, subtracted by the other diagonal, 4 times 9. And 6 times 6 is 36, and 4 times 9 is also 36. And 36 minus 36 is 0, which means there's no inverse, right? If the determinant is 0, there's no inverse. And if you forget, here is why, because the inverse of B is the determinant of B times that matrix 6, negative 4, negative 9, 6. But this is 1 over 0. I'm not even going to write this. And that is undefined. I just dotted an E. Okay. So you don't have to show that. The only thing you have to show is, this is way harder to erase than I anticipated, a statement. And you need to state, since the determinant, here, if you didn't even want to say that, you could use the symbols, is 0, there is no inverse of B. Hopefully you didn't make up any math. Okay, let's do one more example for today. Same type, so determine, actually same directions, okay? Determine if the inverse of A exists. And our matrix A is going to be 2, negative 3, 4, 4. So try to figure out if this works. So same deal, we want to first determine the determinant of A. So I'm going to do 2 times 4 minus negative 3 times 4. So 2 times 4 is 8. Negative 3 times 4 is 12. Oh, there's a negative there, so that's going to be plus 12. So the determinant is 20, which means it does exist. Rewriting that formula in case you're rusty. I always recommend writing the formula out when you're trying to learn a formula, which I've told you many times before. So this is going to be 4, positive 3, negative 4, 2. So remember, we go from A, B, C, D to D, negative B, negative C, A. So applying this, the inverse of A is going to be 1 over 20 times 4, 3, negative 4, 2. I guess we're generalizing it. I wouldn't have written that. Whatever. So this is going to be 4/20ths, which is 1/5. Then 3/20ths, negative 1/5, and then 2/20ths, which is 1/10. And yes, you do need to simplify your fractions. If you don't, you will not receive full credit. So that is it. We're done finding the inverse. And then if we wanted to check, if you weren't sure, we would do A times A inverse. So we could check and do A times A inverse and see if we got the identity matrix. So if you have any questions, please come to Flex Time, but that's it for today.